This is a video on VBA techniques in dealing with manipulating and accessing external data. It's part of the continuing series of videos on Excel and VBA best practices. As a reminder, this video is brought to you by PolarisInvesting.com, a site for creating defensible valuations. We call business valuations based on expectations derived from skillful consideration of past facts and future possibilities. As we've discussed before, the series of videos is broken up primarily into Excel videos. They're more about the way the user interacts with Excel, and then also behind the scenes in working with VBA. This video is about VBA. Those who are a little apprehensive about diving into behind the scenes and VBA in particular, I'd like to offer up a simple way to think about programming in general. And to do that, I'm going to reference this acronym ILA. It stands for if, loop, and assign. And if you just think of ILA, all programs, regardless of the sophistication of the programming language, are doing one of three types of operations. They're either doing some kind of an if statement, and there's several kinds of ifs, embedded ifs, elifs, there's even case statements, but they're all essentially making some decision and taking one action out of many. You have looping, different kinds of loops. You have for loops, you have do while, do until, lots of different ways of looping. And then assigning, which typically is often just setting a variable equal to some value, or setting a property equal to something like that. Ron Olsen is a prolific author on programming, and he expands on this ILA view of programming. In a YouTube presentation on the history of programming, he shows this basic breakdown of a program. And at the bottom, it shows that you assign things to the values to names. You have if conditional type constructs in a language, and then you iterate, also known as looping. Now, he went a little bit further and talked about data types like strings, numerics, booleans. And there are typically some kind of standards around indentation of the program. And then you have structures like arrays to hold values, and hash tables, and things called namespaces, so that you can reuse names in different parts of your code. Now, on top of these basic constructs is different styles of programming. Procedural programming like VBA, object-oriented programming, C++, C#, Java, and then a newer style called functional, which is more of a pure mathematic approach to programming. But regardless of the style, the programs are all built on these basic concepts. Programming, referred to as ILA, its constructs and style, is a relatively small part of the overall software development cycle. The software development cycle consists of phases consisting of defining requirements, designing, developing, programming, coding, testing, deploying, and then maintenance and support. These phases are traditionally considered sequential and referred to as the waterfall approach. A more contemporary approach is called agile, in which the phases are considered iterative. Each iteration results in additional insights about the domain, also known as the subject matter, and the programming environment. All right, so to demystify programming, particularly in VBA, let's look at some code in a VBA function with the acronym ILA in mind. Well, VBA is a procedural language. It requires all variables to be typed. Variables are typically typed to be integer, there may be string, they're going to be double, means that there's going to be floating point type numbers. You can also indicate variant, which means that you allow VBA during runtime to determine the proper type for a particular variable. Then you can see here that we have this assignments going on to those variables. And then later on we see a for loop that's looping through until it hits the max value that it's going to loop through. Later on you see here a do. Now this is another type of looping, but it's doing a do loop while some condition is true. And here you see an if statement that looks through some conditions, and if the condition's true, then it does some things. And like I said earlier, you can also have else if. Instead of just ending the if, you can have else if. You can also have a case statement, which is shown in another part of code here, but this is just a more elaborate way of doing nested if statements, essentially. So as you're looking through VBA code, just remember ILA. Either you're doing some kind of if conditional statement, you're either looping or you're assigning. Now armed with this introduction to VBA, let's briefly compare procedural languages to object-oriented programming languages before proceeding into more details of VBA. A procedural language like VBA loosely couples procedures and data. The programmer has the freedom to associate procedures and data as they see fit. An object-oriented language is a rigorous implementation of good programming practices centered around tightly coupling procedures and data into objects. A significant downside of the freedom of procedural languages is often spaghetti code, which is difficult to maintain. A significant downside of object-oriented languages is often bloat, which creates added complexity, resulting in a vast amount of code that is difficult to maintain. A good programmer, regardless of programming language, should be trusted to follow good programming practices. Well, let's talk about where most people start off their journey into VBA. They start off in Excel, do a lot of things through Excel, but then they start recording macros in an effort to automate some things that they're doing. And then from there, they start looking at the macros that get generated and start learning how VBA coded up the steps that they recorded. So let's quickly go through the steps to record a macro. So you go out to developer and start up the record macro. Give it a name. I'm just going to call it try it. And going to base this on the use of the advanced filters. We've done this in other videos, but start off, I'm going to highlight the data that I'm interested in filtering. Go out to the data tab, select advanced filter. I have run it before, so it's already aware of the list range, which I do have highlighted. The criteria range, typically that would be blank, but I just go up here and for advanced filter indicate with the field names that I want to filter on. And then I also indicate where I want to copy it to, and again this would normally be blank first time I run it. And then tell it what field names I want to use, and I indicate OK, and Excel runs it. Then I come back over here to the developer tab and I stop the recording. Alright, to see the VBA that got generated, just go to the Visual Basic and Module 6, because I knew I had these other modules already created. And again, a module is a place to store code. Previously we looked at some code in Module 2, Module 3, but you can create as many modules as you want. Here VBA or Excel automatically created a new module. So we see the kind of code it generated. It took the range A4 to C19, which is where the data is at, and then calls the advanced filter with some specific parameters. It also created a named range called record criteria. Let's go out here and manually clear where the result set is currently at. And now let's go into this VBA code and simply run it. You can see here we ran it again, and there's the results set from the advanced filter that we automated. Recording macros is a reasonable way to automate some steps, and it's really useful to go look at the code that Excel generated to get ideas of how to do things yourself. As you get more and more advanced with things that you want to do in the VBA code, you're going to run out of the ability to just record a macro. So macro recording becomes more for looking at examples to hone your VBA skills. All right, the next topic here is we'll talk about calling functions and subroutines. And this issue with writing to cells that you should be well aware of. So here in the QueryIt spreadsheet, I want to look at what's going on behind the scenes. If I type in ms star and hit return, this pop-up occurs, and then we get a result set display. Well, if we go look at what actually happened from a code standpoint, is this page 1 worksheet has a essentially a module named after the name of the worksheet, namely page 1. And we'll talk about this more, about these concept of these events that are specific to worksheets. But here we have the change event. So as soon as I typed in ms star and hit return, that cell changed, and it caused this change event relative to the page 1 worksheet to be the subroutine to be executed. Now, important, it's subroutine that gets executed in response to that event. So the first thing that we're doing in this event right now is we're looking at, well, what cell changed? That's referred to that by the target address. And if it's A1 that changed, then we want to call, could be either a function or a subroutine. But I want to pay attention to this comment here. It says writing to cells must be initiated from a subroutine, not a function. So events dealing with worksheets are subroutines. Therefore, we can call a function or a subroutine, and it can successfully write back to cells in the worksheet. So let's follow this through. It calls DisplayIt. Well, that's in module 5, and here we are. You notice it's defined as a sub, and there's no input parameters or output parameters. It goes through and it runs the query, which is a call to a function. The reason this is declared to be a function is because it does return something back to the caller. In this case, this subroutine called DisplayIt. And then it's the result of the query, and then this will actually end up writing to the cells. Okay, let's back up here and follow a little more carefully the execution path. Once the user types in something here in cell A1, this page 1 change event subroutine gets invoked. We check for the target address. It is A1 that changed. And now we're calling a subroutine called DisplayIt. Again, a subroutine calling a subroutine. Now there are different ways to call a subroutine. One way is like shown, or you could drop call and just type in DisplayIt. Now if this subroutine DisplayIt had parameters, you could pass the parameters in two different ways. You can either do it with a inside parentheses, parameter 1, parameter 2, parameter 3, right parentheses, or you're just going to omit the parentheses and call a subroutine this way. Now, if you were calling a function instead of a subroutine, there's no difference. The only real difference between a function and a subroutine is the function is able to return a value. So in your code, if you were calling a function, you would do something like this. You would have maybe a variable a, and you would set it equal to some function a that you're calling, and call it this way if there's no parameters, or that way if there's no parameters. If you do have parameters, you would type in, just like with the subroutine, the different parameters, and then it would return, if it's set up, a value that could be immediately assigned to a variable. But a function doesn't have to return a value, and then it could just be called just like a subroutine. Since we're already discussing parameter passing, I want to go into a key concept that's better explained if we go to a more involved function. So down here, there's a function called EOD single, and you see here the parameter in the definition of the function has ByValue, but typically you don't specify a reference type of ByValue or ByReference. But in some cases, you need to be explicit about when a parameter is passed into a function, which type of reference do you want to use. Now the big difference is ByValue means that when this function is called, this parameter is actually copied from the caller, and then if changes are made to the parameter in this function, like it is here, it doesn't impact caller's instance of this variable ticker. Whereas if there's no value type declared, the default in VBA is by reference, and that means when the caller calls this function, it's actually passing a pointer to the same instance of the value, in this case ticker. So as the function makes changes to ticker, it also changes the value that the caller is working with. Now this is really confusing because if you go out and look in Google, you'll see here when I googled Excel VBA by reference as default, it says passing variables by reference is the default, which it is in VBA. But if you would just change the search to this, it comes back and says ByValue is the default. Well, there's quite a difference in behavior that you'll get if you assume one default versus the other. Well, it turns out that there's inconsistent information out there on the internet, and VBA is by default the way the first search came up with, namely by reference. So a pointer is passed in, so any changes made here in this function to the parameter is also impacting the same instance of this value ticker in the code that's calling this function. So as shown here, didn't want that behavior, so we overrode the default to ByValue, and so now the function is dealing with a separate copy of this variable called ticker. Now, why does Google sometimes return that the default is ByValue? It's because there's a difference between Excel VBA code and Visual Studio .NET Visual Basic. If you're using Visual Basic to write a standalone program, the default call type is ByValue. But when you're using VBA in Excel, the default call type is by reference. This is likely done to minimize memory usage since only a pointer is passed. So returning back to what the code originally looked like, all we see here in this code is call display it. Really don't know looking at this whether we're calling a function or a subroutine. So if we go look, we see that it is actually a subroutine and that has no input parameters. So the question comes up, why can't you define the sub as a function that returns no values? And in this case, it's no parameters. So instead of, and you can see here that VBA automatically changes it for you to in function. So you got a function. So would that work? Well, let's go back here and run it. If you recall, if we put in blank, it returns blank. Now if we run it again, and you can see here that the code is running and it returns back a result set. So yes, you can run this when this is defined as a function. Well, now that it's defined as a function, I should be able to run it from Excel. Just go to a cell over here and type in, in fact you can see it even finds autofills with display it. So there's no parameters, and heck, I'll just call it directly from this cell. But I get an error. Well, the reason you get an error is because further down in this code we use the cells command right here to to write back to specific cells in the page 1 worksheet. And unless, as we stated earlier, unless you initiate calling a function or a subroutine from a sub, you're not allowed to write back to cells. And that's what we've done here, is we didn't initiate the calling of the function, display it, from a sub. It was initiated directly from Excel. Now the reason I believe that Excel has this limitation is because otherwise you would get into circular issues with recalculation. And this kind of brings back to, you got to understand what you're doing. You're a VBA programmer. You're still working through Mr. Excel. He still checks things out to make sure that you're doing things that he agrees with. And here's a case where you're trying to do something that he won't allow. So if your VBA code is doing something that you really don't want an Excel user to be able to invoke as a function, particularly if you're doing something that will throw up an error if it is attempted to be run as a function, it's best to declare it as a subroutine. And that way, when if a user were to somehow know about it, first of all, how would they know about it? Because if they try to type it in, it's no longer being auto-filled. It's no longer being advertised as even being an available function. And if they were to type it in, it's not even showing up as a legitimate function, so there's no wonder that you get this error that the function is not valid. So big benefit of making a subroutine versus a function is just not available as a function call to an Excel user. One other thing to be on the lookout for is if you were to define something to be a function that probably should be a subroutine, particularly something like this that writes to cells. But if you were to do this and in the code you were to have a statement like this, OnError, go to an error handler, and then here at the bottom, let's say you just have it do nothing. Just say error handler, and then it just exits the subroutine. All right, now it's a function, and if we come over here and now execute display it, now you don't even know what's going on. You just get back nothing because it's a function, and we didn't even define a return value for it, and yet so Excel just displays a 0. The next listed topic for this video is error handling, but we just went through error handling, and plus in the previous video we went through error handling when we were talking about the JSON parser. So there's only one additional thing I want to mention about error handling is that up to now we've in the videos we talked about error handling being done such that you just say OnError, go to some error handle label, and then you usually just exit from there. Well, what you could add is you throw up a message box or do some logic around the actual error number. For instance, this writing issue that we talked about, if you write from a function or a function that's called from Excel, you'll actually get an error number 1004. So this is the way you would actually determine the actual error that was run into. There's also an error description that you could also do something with. Now one last thing here is instead of going OnError to an error handler, you could opt to just say OnError, resume next. It just essentially tells VBA to ignore the error and just go to the next executable step in the code wherever you're at. But that could cause downstream problems because the previous step didn't complete successfully, so it's really not recommended to use OnError, resume next. The following has been added to the video since it was originally recorded. Normally the code that handles an error soon exits the subroutine or function it is in. Just like with resume command, exiting terminates the handling of the error. Until exiting or executing the resume command, the code is considered to be handling the error. Subsequent errors while handling the existing error causes the code to abort. If an error is handled in a loop, You must use the resume command in order to handle subsequent errors while processing the loop. And that is shown in this code here, where you're in a loop, starts here, the loop ends here, and in the middle of this looping, there's an OnError condition. You can see here the way that error, if it occurs, handles is that a resume command is given, and then the loop is continued. All right, back to the original video. I'm going to move on to the next topic, which is on worksheet events, which we've alluded to some already in this video, but just to talk about it as specifically. I'm going to go out here and I'm going to create a new worksheet. Let's call it sheet 2, leave it at that. And now I come up here to the developer tab, and you see here that there's sheet 2 that's been module essentially that's been created, and it's empty. Well, if I come up here and select worksheet, it automatically populates a subroutine for an event that it thinks that I might want to provide some code for, and that has to do with if there's ever a selection change. So if a user just simply clicks on another cell, it's changing, the user's changing the target address. Target address is D1, C1, D3, E4. User can even select a range. Make note, you must use an absolute address like $A, $1 when comparing a target address to a specific cell address. So that's one event that you typically do want to handle. Another event that, in fact, here's all the events that you could write code for, but the other two most common ones is if there's a change event. Unlike clicking on it, it means that the user's gone to a cell, here let's say B2, and maybe cleared the cell, entered a value, did something, but changed the value in that cell. So that would cause this event to be triggered, and then you would also look at the target address to see what action to take based on what cell actually got changed. And then the third event, calculate event. So this would be not when someone clicks on the cell or someone changes the cell, but if it was, let's say, a formula in a cell, and now that cell got recalculated, you would specify a specific target address or range, and then execute some code based on that. Now these other events might be a cause for you to want to do something like if the worksheet gets activated, meaning a user selects the worksheet, you can have code that gets executed on that kind of event. If a user clicks on another worksheet, thus leaving the current worksheet, you can have code that gets executed on worksheet deactivation. So all these at some point may be useful events for you to write code for. Now the thing you should know about these events is that at the end of the event is when this code gets called. So let's say on calculation, all the calculation in this cycle is done, and at the end of that calculation cycle, then this code in this event handler is called. The other thing I want to make sure you understand is when you're talking about this worksheet change event, you're talking about really a user change event. So the target address is that individual cell or range of cells that a user changed, and not all the downstream cell changes that have possibly formulas that reference upstream cell changes. This next topic is related to worksheet events because it's typically in those kinds of event code that you end up needing to do look for cell changes in a particular range. And so to look at this closer, we're going to look at the FilterTest spreadsheet. In particular, I'm going to go off and look at this page 1, and you see here we got a worksheet change event. And the first thing it does is it looks at the target address, and which can be, it says target.cells, which could be a range, and if the count is greater than 1, it's just going to exit the sub and saying, look, we're only looking for one cell to change, not a range of cells. Then it goes further, and it then goes off and it says if the region equal to 1, you're going to clear. So that means that if all these individual cells that make up the advanced filter have been cleared out one by one. If I try to clear them all out at the same time, that's a range. But it's just set up that if there's no criteria left, it'll then clear out. But as you're just changing, clearing one, the query will rerun. But then when there's no criteria left, it clears the results. Alright, so if that's not true, then it comes up here and does something a little more tricky where there's this thing called Application.Intersect, where you can look at the target address and see if it intersects with a range that you're interested in. And the what's available in VBA is it just has this is nothing. Well, often you want to know if it's something. So what you do is you take the nod of all that, and that tells you if there's something in this range that's actually changed. And then here you can see that we call the advanced filter. So what this is doing is it's saying that the range that A1 is a part of, if anything changes in here, we're going to call the advanced filter. Now to look at some other things that you can have in that kind of code, we've talked about looking for target addresses or counts in this exiting the sub. You can also look for just how many rows are in the target that's been passed in, or how many columns, and then possibly exit. And then this one down here, we've already talked about that. We use the Application.Intersect. This just adds an AND condition, and it's kind of a tricky way that it multiplies the number of rows times the number of columns, and if it's if it's equal to 1, meaning only one cell, one item in a row, one item in a cell, then it's similar to this up here. But instead of checking for it up here, you just wait and check to make sure you've only got a single cell changing before you take action. And then this is somewhat equivalent way of doing the intersect. And we'll see this kind of code when we look closer at the trace function, because often when you're tracing, you don't want to know about all cells that are you don't want to trace all the cells that maybe you're changing. You want to target specific columns or specific rows, and maybe only individual changes within that range. Since this video was originally recorded, a trickier scenario involving the use of the intersect function has been identified. The scenario is detecting if a user has only selected cells in a specific range. Previous examples used the intersect function to identify if cells in a range were included in a selection, but not exclusively. A concise way to identify that only cells in a specific range have been selected involves handling the condition if no cells in a specific range were selected. In this case, a null address is returned and causes a runtime error when compared to target address. To sidestep the runtime error, a non-empty range is used if intersect between the target range selected and the specific range interested in is nothing. The non-empty range is a range that the user will never select. Thus, its address will never be equal to the target address. In this example, the cell in column ZZZ row 10,000 is used. Assuming the user makes a selection that includes column D, the target address will only equal the address of the intersect of target and range of column D if the user only selected cells in column D. Other things to notice in this example. First, intersect is not preceded by application. The inclusion of application dot when using intersect is optional. Second, target is used, but selection could have been used. Best to use target in worksheet events. It is suggested that you pause this video to more closely review the table that compares target versus selection. Okay, back to the original video. The next topic in this video is we're going to talk about how do you control recalculation in a spreadsheet. We're going to use this QueryIt spreadsheet to demonstrate how you do that. This is actually a pretty powerful feature that, like Google Sheets, that does not even have functionality to control recalculation. Main way you do that is through calling application.calculation equals something. And in this case, here in the code, we are turning calculation to manual, which means that calculation is essentially suspended until later in the code you start calculation back up being automatic, meaning it goes back to being, as things change, Excel automatically recalculates when it needs to. Other things that go along with recalculation has to do with setting certain things defaults and then setting them back to true once you've re-enabled calculations. Things you typically set defaults before stopping calculations include screen updating, alerts, and events. Once calculation is off, you update cells. After cells are updated, you turn calculation back on, enable events, enable alerts, and then re-enable screen updating so users can see the changed cells. It is good practice to follow screen updating with DoEvents. DoEvents temporarily hands control back to the operating system, allowing it to process other events, such as completing screen updates. Besides turning calculation on and off for the entire workbook, you can control calculation down to worksheets and a specific range. As shown in this code snippet, sometimes you must wait for pending calculation to finish. Typically, calculation is a blocking operation, but if the calculation includes complex formulas or functions with asynchronous activities like internet communication, then execution may proceed while calculation is pending, thus requiring waiting for pending calculation to finish. This next topic in this video on moving data between Excel cells and VBA is one of the most important topics in the whole series of videos on Excel and VBA best practices. So let's go back and look at this QueryIt spreadsheet. Go back to the DisplayIt subroutine that gets called from Excel by changing cell A1 here on the page 1 worksheet. Well, if we focus on this subroutine here, we see that the first thing it does is it clears off in the page 1 worksheet the landing area for the query results that we're eventually going to retrieve and display. We then, as previously discussed, turn off things, in particular manual calculation, so that as we're doing things later here in the subroutine, they're not user-facing at all to the Excel user until we get to the very end, and then we start up calculation again and then display it. Well, the next thing done is we go get the data using the QueryIt function. We will be discussing in detail the QueryIt function in a subsequent video, but now going to cover some demonstration code in the QueryIt function that explicitly demonstrates the moving of data to and from arrays and cells. Preceding the demonstration code, you see the use of the Polaris TransposeArray function to transpose data in the row array and assign it to QueryIt. The demonstration code shows why the TransposeArray function is required. The demonstration code starts off by assigning data to an array. Now, it's very important to note that you must assign multiple cells to an array. It then assigns the array to a range of columns in a single row. A single dimension array is one row with multiple columns and indexed 0 to n-1. When assigning the single dimension array to cells, the cell range is filled horizontally across columns. The cell range must exactly match the array, meaning it must be a range of columns with the exact number of columns as the array. Next, the demonstration code places the array data in rows by first transposing the array using the xlTranspose function. Note, the xlTranspose function indexes the output array from 1 to n. Next, the demonstration code assigns the transpose array to a range of rows, each consisting of a single column. When assigning the transposed array to cells, the cell range is filled vertically down rows. The cell range must exactly match the array, meaning it must be a range of rows with the exact number of rows as the array. Next, the demonstration code uses the xlTranspose function to transpose the array back to columns. Notice the array returns to being a one-dimensional array, but it is now indexed 1 to n, not 0 to n minus 1 as it was originally. This is because the xlTranspose function always reindexes an array to 1 to n. Lastly, the demonstration code shows the difference between the xlTranspose function and the Polaris TransposeArray function. First, the xlTranspose function is used to create a one-dimensional row array that is indexed 1 to n. Next, the Polaris TransposeArray function transposes the array to a column array. The resulting array is indexed 1 to n because the Polaris TransposeArray function always dimensions a two-dimensional array using the same indexing as the source array. Note, the Polaris TransposeArray function transposes all array elements regardless of their value. The xlTranspose function silently terminates when encountering a blank array element. Now that we've been through the demonstration code, I'm going to turn it on to execute the code. As the code is executed, you can follow along here to the right. So initially, we're seeing the columns code being executed. The dimension is one dimension array, 2 elements, and here's the results. Notice the indexing is 0 to 2. Then we go to rows. It's a 2-dimension array of 3 by 1. And then you can see the indexing is 1 by 1, 2 by 1, 3 by 1. And then we return back to column. You can see that we've got a one-dimensional array, but the indexing is 1, 2, and 3 versus 0, 1, and 2. And then we do the Polaris comparison, and you can see that a two-dimensional array of 1, 1, 1, 2, and 1, 3. Now, could have used Excel's built-in Power Query instead. If you were to use Power Query, you would use code similar to this, with a query defined in Power Query, likely named QueryIt, to pull back the query results. Whether you use Power Query or QueryIt function, you end up with query results in this query array. The query array is defined to be variant. Unlike other variables here that have explicit types, a variant type defers typing until runtime, determined based on the object assigned to the variable. Now, right after this loading of the query array, to have a commented out message box, I'm going to go ahead and, for now, uncomment that. And now let's go run the code here. And you can see the pop-up that I just added shows us the dimensions, the two-dimensional array that we get back from the query results. We get the first dimension is the rows, but you can see here the rows range from 0 to 11. So arrays are always 0 to n minus 1, whereas in Excel we're used to thinking of things in terms of 1 to n. Well, yeah, the second dimension is the columns, and again it starts at 0 and not 1, and it goes from 0 to 6. And then we get our results. Well, let's look at how these results actually got moved into the Excel cells. You can see here that after we get the query results in the query array, and by the way, I'm going to go ahead and uncomment or comment this back now that we're done with that. But there's two approaches. One is called bulk, and the other is just if we take the else condition, if we're not bulking, we're going to just loop through all the rows and cells and move things over one value at a time. In this code, the way that that's controlled is just over here by a selection the user can make in the Manage tab. Right now we have it set to bulk. Let's go back and look at the one line of code that bulks in data from the query array into the Excel cells. I'll stress it's one line of code. Now, for this to work properly, the destination cells, the range that you're specifying, has to be exactly equal to the range of the query array. Now, if you recall, a query array was a dimension 1 was 0 by 11, so that's 12 rows, and dimension 2, which is a column, was 0 by 6. Now, in Excel, we deal the user deals with rows 1 to n and columns 1 to n. So we've got to add a 1 to the upper bound. This upper bound gives you the upper bound of the second dimension of the array, and then you also need to add a 1 to the upper bound of the first dimension of the array. Here's the left-hand corner, A3, where we want to start putting it, and then the data will end up in G14. So if we go back and look at the code, we will end up with 14 for the, because we're starting 2 rows down, so we add a 2 plus the 1 difference between 0 to n minus 1 versus 1 to n. So this results in 14. And then this results in the column G because we're not offsetting from column A, so we just have a 0, and then because of the 0 to n minus 1, 1 to n difference, we just add a 1. So it moves it in one statement. Up until now, we've been talking about assigning an array to an Excel cell range. When doing the opposite, namely assigning an Excel cell range to a variant array, the variant array is indexed 1 to n, not 0 to n minus 1. This is because variant array indexing is based on how it is assigned. Well, let's compare this approach to doing the non-bulk approach, which is one cell at a time. So we're going to come over here and select cell. And now when I, let's go ahead and clear. And now when I run it again, it ran and populated the result set in Excel. So it functionally performed the same thing, but it did it in a much less efficient way. It looped through. The outer loop is the rows 0 to 11, so 12 different rows. The inner for loop is looping through each column 0 through 6. So the total number of assignments that it has to make to cells, which it's doing here, is 84 different assignments. 12 rows, 7 columns per row. Compare that to what we did with the bulk. Bulk was 1 assignment. Well, watching the result sets get displayed over here between the bulk and the individual cell approach to populating the cells, it didn't appear that there was that much of a time difference between the two. But the problem is that we need to have a more exact way of measuring that in order to conclude whether there's a big time difference or not. So here in the code we do use get tick count to record the start time, and then here we record the end time, and then optionally display it based on a value in the Manage tab. But this code actually here is not in the right place. So we need to move this code down to on the other side of where the it's actually displayed, but also need to copy the setting of the start time to here. Alright, so let's go out to the Manage tab, and we're in the bulk method, and now let's do that we want to display the time that it takes. And now let's go run the query. And you can see here that it takes 125 milliseconds in the bulk approach. We clear and go back out to the Manage. Now instead of bulk, we're going to use the cell approach. Run the query. And you can see it takes 140 milliseconds. Well, 125 milliseconds versus 140 milliseconds on the surface doesn't sound like much of a difference. We're only manipulating and displaying 12 rows. If we were to do 5,000 rows, let's say, with the same number of columns, and assuming that things scale linearly, we could be looking at that same time difference could cause over a 6-second difference. So it adds up quickly. The time difference gets even larger when you consider situations where maybe you can't turn off calculation. So to see that, we go out here to the Manage tab, and we have a flag that we can turn calculation back on. And now let's go back to the bulk case, and now run query. And we can see here it takes still 140 milliseconds. Let's clear out the results. Go back and now do the cell. And it takes much longer, 1,422 milliseconds. So enormous difference. Let's consider another scenario with recalculation turned on. That is downstream formula references and other cells to the cells that might be changing. And a way to simulate that here is using something we talked about way back in the Excel cell references video. But in that video we talked about how you can have a volatile function that's not even in the execution path, yet every time that volatile function changes, the formula is re-executed. So here we have a spin count, which is spins for, in this case, 25 milliseconds. And yeah, when I run it, it runs one time. But because it's referencing in the formula a volatile function, every time there's a recalculation anywhere on the spreadsheet, this formula will rerun. So let's go off to the Manage tab and do a test with the bulk and see how long that takes. You can see it comes back with 156 milliseconds, which was a little longer than what we saw when we weren't trying to simulate this downstream recalculation of other formulas. Now let's do it, so it's not real bad, but let's do it here for the cell, individual cells. That means every time a cell is updated, a recalculation is done, causes this function to be reevaluated, and because of the volatile function now, and it'll spin for 25 milliseconds in between every one of the field updates. And because we're doing 12 rows, 7 columns, that's 84 times we'll be spinning 25 milliseconds. So when we run that, we see 2,750 milliseconds elapse, so significantly longer. Thinking about it, we have 12 rows, 7 columns. That's 84 updates. And we add a 25 millisecond delay. Multiply 84 by 25 and you get 2100. And that accounts for the majority of the additional time that it takes. Okay, we've seen here how relatively minor decisions around how to move data around can have significant impact on performance, particularly if you're dealing with situations that require that calculation stay on. Since this video was originally recorded, another topic has come up that we wanted to discuss here, and that is moving array data between a function and the caller of the function. So here what we've got is an example of that, where a function called Polaris usage is being called, and it returns back an array. You can see here in the caller you declare the array to be a variant, and you declare it this way with open and close parentheses. And then when the array comes back, it's a 0 to n-1 referenced array, and you can see that the return values are placed in cells C26 and C27. So let's go ahead and run this. And the way it's run is by just selecting C25 on the Manage worksheet. It invokes this. So it'll clear C26, C27, wait a second, and then call the function, and then what is returned from that function, the array, is displayed in the C26 and C27. So I'm selecting C25, it clears, and then here a second later it's returned the values from the function. So let's go look at the function. You see here the function is making a SQL Server call. When the store procedure is done, it returns a two-dimensional array, but column first, then row. And then, as I already said, 0 to n minus 1. So right before it returns, it does a transpose array, which has been discussed previously, to convert column row to row column. And then it comes back to the caller, and then the caller just simply sets the return value to this variant array. Now we'll point out here that you declare the return value as a variant array. So it's a very straightforward way to do it, but you do end up in the caller with an array that is referenced from 0 to n minus 1 in each dimension. Excel users tend to think of rows from 1 to n, and even columns from 1 to n. And to demonstrate that, I've got a formula that's just simply bringing back the row and column numbers. And you can see here that here in row 7, this first column is 7, 1. And if we extend this out a couple columns and then down a couple of rows, you can see that 1 to n in both dimension, row and column. Viewing array data in terms of 1 to n is used by two Polaris provided functions to extract column delimited and JSON data from a string, namely comma delimited split out function, where you pass in 1 to n for the row and 1 to n for the column. And you can even see here that array is 0 to n minus 1, so these parameters, when they're passed in, 1 is subtracted off of them, both for the row and the column, in order to reference the correct spot in this comma delimited string. JSON parser works similarly in that you pass in a row or an instance and then a column name. So referencing array data from 1 to n provides consistency with how an Excel user is used to referencing data that is arranged in rows and columns. So let's see what it would take for a caller of a function to reference array data from that function from 1 to n versus 0 to n minus 1. Assuming the call function was rewritten to return an array 1 to n, when the function return value is set to the variant array in the caller, you end up with an array 0 to n minus 1. You could try to redimension the array to 1 to n, but there are severe limitations with the ReDim Preserve statement when dealing with a populated array. Namely, you can only redimension the last array dimension. And Preserve only allows changing the upper bound of the dimension. The lower bound must be established before the array is populated. You can't redimension the caller's array before calling the function because you don't necessarily know the dimension sizes before calling the function. What's required is a different approach, namely taking advantage of Excel's VBA default reference type, namely ByRef, and passing in the variant array as an input parameter when you're calling the function. The Polaris usage function has also been updated to return array data is either a 1 to n referenced array or comma delimited string or as a JSON string based on the format type passed in the first parameter. You can see that no matter how the return values are formatted, rows and columns are consistently referenced from 1 to n. Namely, if you ask for an array, you get row column. If you ask for comma delimited data, you reference row column, and JSON, instance or a row, and then the name of the column. So let's see how this Polaris usage function has been rewritten. Notice there's now two input parameters, namely a format type and then the variant array that will be returned. I notice here the keyword ByRef has been added, but that's not needed because the default reference type is ByRef, which means a pointer is passed in. So any changes made to the destination array will be reflected in the caller's array input parameter, namely here. So if the function redimensions that array, it'll be returned to the caller. Okay, returning to the updated Polaris usage function, you see as before, SQL Server is called, the stored procedure is executed. If it's successful, the return array is column row 0 to n minus 1. So typically what you see next is a call to the transpose function, but transpose function will return a 0 to n minus 1 row column array, and we want not only row column row changed to row column, but we also want the reference of 0 to n minus 1 changed to 1 minus n. So the way you've got to do that, first of all, we check to see if the format type is asked to be array, and then immediately redimension the array that's going to be returned to 1 to the upper bound of the row array, and same thing with the column dimension. Note, ReDim is used to dynamically index an array. This is in contrast to dim, which statically indexes an array. Also note, ReDim can be used as a declarative statement if an array is not previously declared with a dim statement. In this context of passing an array into a subroutine, the array must be previously declared. Okay, next the code walks through each column and row of the row array and copies it into the row column of the destination array. And then when it's done, the string that is returned is success. Now, if a format type is not array, but is requested to be column delimited, then you can see here that this works with the row array directly coming as a result of this call to the store procedure. But it formats it in a way that the column delimited function can parse it. If the format type is JSON, similar kind of thing, formats it in a way that the JSON parser can parse the string. So it just works with the row array that's returned by the store procedure. Now normally the caller would select a particular way that wants the array data to be returned to it, and would not follow up with these different if statements. It would just say, okay, I want it, let's say, as array type, and then it would look for just that formatted type of data to be returned. And it's even possible that would not want to have just one general function that handles multiple formats. Polaris usage function itself may be designed to only return array. Then you wouldn't need additional code to handle multiple formats. Since originally recording this video, another useful topic on arrays has come up. You can use xlIndex function in VBA to reference specific rows in specific columns of an array. The highlighted line of code shown moves the first k rows of the second field of a two-dimensional array into cells starting in J10. To understand this code, let's review the xlIndex function. In Excel, the index function is used to return a cell from a range of cells at the intersection of the row number and column number. If the row number is 0, the entire column of values is returned. If the column number is 0, the entire row of values is returned. Often, index function documentation glosses over another option, which is to specify a range of rows or a range of columns. That is what's being done in this code. From an array, a range of rows from 1 to k from column 2 is being placed starting at cell J10 for k rows. Notice the use of the resize property for the range J10. It changes the range to k rows with one column. Internally, this is stored as a two-dimensional array with a single field in the second dimension. The index function internally always returns a two-dimensional array. When requesting rows from a single column, the second dimension contains a single field. When requesting columns from a single row, the second dimension contains fields for each column. This is a convenient approach to extract row values from a specific column of an array. Further down in the code shows using the index function along with the match function to search for a value in a specific range of an array. Note, index function outputs values. It cannot be used as a destination to receive input values. Next, going to discuss how to declare a global variable that can be referenced across all modules and worksheet objects in a project. In the spreadsheet shown, a module 4 has been created, which in it is a publicly declared global variable A. Also defined in this same module 4 is a function that displays the global variable A. Here in the worksheet object named global, also called codename sheet 3, there are two cell selections handled by the SelectionChange event code. When the user selects A1, global variable global var A in module 4 is set equal to the value in cell B2 on the global worksheet. When the user selects A2, the function display it in module 4 is called to display the global variable in Module 4. Setting the global variable in the worksheet object named global and displaying it from the code in Module 4 clearly shows that a global variable can be referenced by any module or worksheet object like Sheet 1, Sheet 2, etc. Now note, public global variables must be declared in a standard module, not in a worksheet object like Sheet 1, Sheet 2. So what that means is this variable, global var A, if it had been defined to be public here in Sheet 3, it would have been visible only within Sheet 3. I'm going to demonstrate the code by setting cell B1 on the global worksheet to 456. Then I'm going to select A1. You can see that the global variable is showing it being 456. Then I'm going to select A2, and now it calls that DisplayIt function in Module 4, displaying the value 456. Next thing we'll talk about is function tracing and timing. These topics have been discussed in other videos, so it'll be a rather brief discussion here. As a reminder, looking at the QueryIt spreadsheet, there's a function called trace, and based on some criteria around what you want to trace, you'll show the function name that's been called, and then the worksheet and the address in that worksheet that called the function. I just added another set of conditions or any formula on the page 1 worksheet that uses the function echo back, and then display the name of the worksheet, which will be page 1, and then the address on that worksheet. If you're using a spreadsheet that's not set up to use tracing, you need to have exit function be the first statement in the trace function. Now the echo back, as a reminder, is a function that you can add to an existing formula. All it does is takes the input value and then echoes it back. So for instance, I've done that here in this worksheet at cell C1, and I took a formula that already existed and I appended onto the back blank character, knowing the spin function returns text. Now if it were to return a number, I would, instead of using this, I would just have it do something like add 0, something that's not going to change the value of the cell. Now the spin function is something that we were just talking about a few minutes ago, and this is simply taking advantage of the get tick count, which we will talk a little bit more again here in a few minutes, but it just spins and get tick count returns number of milliseconds, so you pass in how many milliseconds you're wanting to spin. So back here in Excel, this function here will spin for 50 milliseconds. So let's say you're running this query, but you really don't understand why it's maybe taking as long as it is, and maybe you suspect that some other cell on this worksheet is factoring into the timing, but you're not clear why. So what you can do is come out here to the Manage, turn on the tracing, so that when it makes it to that trace function, it will display things. And you can see here that as soon as we turn it on, we're starting to see some things get displayed. But now we come over here and run the query, and now we see that page 1, cell C1, the echo back function has been called, and it's been called again and again, and then finally we're seeing what we expect for the as we're executing that query, and then yet again we see it, and then finally we see this elapsed time. But the surprising thing may be that that we didn't realize that this cell here, C1, by virtue of what we saw with the echo back, is being called. And we maybe didn't realize that. Maybe didn't realize that now is a volatile function, and things that we've already gone through previously in this video. You weren't aware of that, but now it gives you a better idea of what to look into and look at a formula in a cell as to why it's being recalculated when you didn't even suspect that. Well, in case of this query being run, we can look at the DisplayIt subroutine that we've been looking at in this video, and we realize now that that clear right there, before we've turned off updating the screen, that's going to generate one of those pop-ups of or cell C1, the now volatile function being executed. Then when we clear the next thing, there's a second recalculation. Another recalculation is when the result set is displayed, and then a fourth recalculation is these formulas that if A3 is non-null, it's going to recalculate this formula. So you get 4 echo backs being called as a result of the now volatile function. Last topic is how to time things going on during execution. There are 3 time-related functions provided by Polaris. Are the spin function, the wait loop function, and the timer loop function. So let's talk about each one of these individually. The spin function is dependent on whether you have a 64-bit or a 32-bit OS. And the main difference between the functions is whether a long, which is a 64-bit variable is defined, or whether a 32-bit variable is defined. So as you spin, it's calling the get count, tick count, and then when it gets to the desired number of milliseconds, the function returns. Now, a different way to spin, besides a tight loop like this, can also just use the VBA function, sleep. If you're going to use the sleep function, you want to make sure you publicly declare it. But chose to implement it by default just in a tight loop. The wait loop waits in seconds, but could uncomment the code that uses tick count here and have it wait for a certain number of milliseconds. But we're already doing that with the spin. So I feel like the default way to do the wait loop is to do it in granularity of seconds. Now, as it spins, it actually yields to operating system events like somebody typing on the keyboard. Another way to implement this loop is you could do a VB call to application.wait. Now, if you do that, it does not incorporate DoEvents. So the probably more flexible way to implement this is through the default way of just having a loop and then yielding by this code here. And then the last function is the timer loop. And the timer loop is used to carry out specific actions within a certain time frame. So it's literally a timer. Now this way this particular function is designed to work is you call it to start the timer, end the timer, and when the timer itself expires. So all functionality dealing with the timer is carried out by this one function. So each time it's called for one of these 3 reasons, the timer is turned off. Then it's looked to see if the timer is desired to stay on. And if it is, the beep indicates the timer has just gone off. And then the action you want to take each time the timer expires. And then this code here resets the timer based on a global or a cell value on the managed worksheet. Wanted to pass that in as a parameter, but just could not get that to work. And you can see here that the procedure that gets invoked every time the timer goes off is this timer loop function. Well, we covered a lot of ground in this video. Thanks for watching.